Suppose we want to solve the system a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. In R2, now we suppose a1, a2, b1, b2 are all non-zero. Then a1x plus b1y plus c1 is equal to 0. Implies that a1 b2x plus b1 b2y plus b2 c1 is equal to 0. a2x plus b2y plus c2 is equal to 0 implies that a2 b1x plus b1 b2y plus b1 c2 is equal to 0. Subtracting the second equation from the first, we get a1 b2 minus a2 b1 x is equal to b1 c2 minus b2 c1. a1 b2 minus a2 b1 is not equal to 0. Then x is equal to b1 c2 minus b2 c1 upon a1 b2 minus a2 b1 is equal to determinants of b1 c1 b2 c2 upon a1 b1 a2 b2. Again, a1x plus b1y plus c1 is equal to 0 implies that a1 a2x plus a2 b1y plus a2 c1 is equal to 0. a2x plus b2y plus c2 is equal to 0 implies that a1 a2x plus a1 b2y plus a1 c2 is equal to 0. We get a1 b2 minus a2 b1y is equal to a2 c1 minus a1 c2. If a1 b2 minus a2 b1 is not equal to 0, then y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1 is equal to determinants of c1 a1 c2 a2 upon determinants of a1 b1 a2 b2 is equal to minus determinants of a1 c1 a2 c2 upon determinants of a1 b1 a2 b2. Thus, if a1 b2 minus a2 b1 is not equal to 0, the unique solution of the given system is given by x, y is equal to determinant of b1 c1 b2 c2 upon a1 b1 a2 b2 minus determinant of a1 c1 a2 c2 upon determinant of a1 b1 a2 b2. This formula is known as Cramer's rule. a1 b2 minus a2 b1 is equal to 0, but b1 c2 minus b2 c1 is not equal to 0, or c1 a2 minus c2 a1 is not equal to 0, Now suppose A1 B2 minus A2 B1 is equal to B1 C2 minus B2 C1 is equal to C1 A2 minus C2 A1 is equal to 0. Since A1 is not equal to 0, A2 is not equal to 0, we can take B1 by A1 is equal to B2 by A2 is equal to K, and C1 by A1 is equal to C2 by A2 is equal to P, where B1 is equal to A1K and C1 is equal to A1P, where B2 is equal to A2K and C2 is equal to A2P. Thus given system becomes A1x plus A1k into y plus A1p is equal to 0. A2x plus A2k into y plus A2p is equal to 0. By dividing the first equation by A1 and the second by A2, we get the same equation, which is x plus ky plus p is equal to 0. The solution set of the systems is xy, a1x plus b1y plus c1 is equal to 0. Thus, in this case, the system has infinitely many solutions. For the equations, if A1 is equal to KA2, B1 is equal to KB2, C1 is equal to KC2, where K belongs to R minus 0, then the two equations are called identical. Two non-identical equations in R2 has unique solution if A1B2 minus A2B1 is not equal to 0, and in case of A1B2 minus A2B1 is equal to 0, the solution set is empty.